We are gonna get started. We have got a Pear Deck activity to try today. Hopefully it works better than it did on Wednesday for my other classes. I had to make some adjustments to it because it wasn't quite cooperating with me. So hopefully it works. And hopefully it helps you make a little more sense out of section 8.3. That's the goal. That's why we do this. So I'm going to put the link for the Pear Deck into the chat so you guys can get in on that. That should be popping through here in just a moment. And we will share my screen so you have the option to go to joinpd.com and use the class code as well. So we're going to get started. All right, we are completing our study of section 8.3, estimating a population mean. And this is the last section in chapter 8, estimating with confidence. All right, here's a quick review of the key concepts that you should know, or you should at least have in your notes for section 8.3. If you have nothing else in your notes for section 8.3, you should at least have these things. All right, these are the takeaways. These are the things you should know. So we have the key concepts here. Conditions for constructing a confidence interval about a mean. It needs to be random, right? It should come from an SRS or some randomized sample. We need to meet the 10% condition when sampling without replacement. And we must check the normal/large sample condition. Right? And that means that our sample needs to come from a population that is normally distributed, or it needs to come from a large enough sample. Right? Our sample needs to be larger than 30. And that goes back to our central limit theorem from last chapter. If those two conditions are not met, we then must graph our sample data, a dot plot, histogram, box plot, depends on the data we have and how much, what we want to look at. And we need to check its normality. We need to see, is it skewed and is it strongly skewed? If it's slightly skewed, it'll be okay. But if we have a strong skew, no good. Or if there's extreme outliers, no good. We cannot continue. We then use the one sample t interval for a population mean. That is our inference method. Right? When the conditions are met, a C% confidence interval for the unknown mean mu is x bar plus or minus t star times s sub x divided by square root of n. X bar is the sample mean. T star is our critical value from table B based on the degrees of freedom. S sub x is the sample standard deviation, right? And the square root of n, right? N is our sample size, right? The S sub x divided by square root of n is the standard error. T star times the standard error is the margin of error, right? Choosing a sample size for a desired margin of error when estimating mu. Just like with a proportion, we can estimate a necessary sample size to get a target confidence level and margin of error. When doing this for a mean, we need to have a reasonable value for the population standard deviation from an earlier study or pilot study or something. We need to have some value to use for the standard deviation. We do not have a default value like we do with the proportions. Once we have that value, we then find a critical value z star from a standard normal curve based on the confidence level that we want. All right, so we're going back to table A for this one. And we then solve the inequality for the margin of error for n. All right, and we use that margin of error equation. And since we know the margin of error we're targeting, we set that to the right-hand side of the inequality and we solve for n. And then lastly here, our confidence interval is a four-step process. Whether we are dealing with a confidence interval for a proportion or a mean or some other statistic, we should always follow the four-step process to make sure we cover all of our bases and we solve the problem appropriately. We need to state what we're going to do. What parameter do you want to estimate and at what confidence level? We plan. We identify the appropriate inference method, one sample t interval for a mean, one sample z interval for a proportion, right? And we check our conditions, random 10% normal large sample or random 10% large counts. Right? If the conditions are met, we perform calculations. We move on to the do step. Then finally, we conclude, we interpret our interval in the context of the problem. Right? That is a very important step. You can do all of the work, all of the correct math, but if you fail to write your conclusion, you have not completely answered the question. You will not receive full credit. Right? That's a very important step. Right? Does anyone need a moment to write anything down from our summary slide here? Please raise your hand. All right, I see no hands, so we're going to continue. We get our first question here, the multiple choice question. Why t? One reason for using a t distribution instead of the standard normal curve to find critical values when calculating a level C confidence interval for a population mean is that. Please choose the correct option. There is only one correct option here. Please read carefully and make your selection. Alrighty, real quickly, make a guess. Okay, we're doing multiple choice questions because you will have to answer multiple choice questions on the AP exam. Chances are, based on the version our district is probably going to choose, it's going to be a lot of multiple choice. All right, you're going to rob yourself the opportunity of getting a correct answer by not answering. Right, practice multiple choice questions. That's why we're doing it. Alrighty, so it appears as though the most popular answer is the correct answer. As far as the most popular answer chosen here, we have 5 students who selected it. And that answer is B. Z requires that you know the population standard deviation, which is why we cannot use a z-score. We don't know the standard deviation of the population, so we use an alternative, the t-value. All right. Is there anything I can clarify? Any questions on this first multiple choice question? Okie dokie, let's move it on forward. Critical value. All right, you have an SRS of 23 observations from a large population. The distribution of sample values is roughly symmetric with no outliers. What critical value would you use to obtain a 98% confidence interval for the mean of the population? You have a copy of Table B here that you should be able to click on. If you cannot, there's the link for that Table B in the chat. All right, make a quick selection. We're going to talk about this one. All right, so we have a tie for the most popular answer here between option D and option E. Let's find out which of the most popular answers is correct. Just want to click, go. It is 2.508 as our critical value, the T star value from Table B. All right, so let's consult why this happened. How did we get this from Table B? I'll show you. So on this multiple choice question, we have a sample size of 23, which provides us a degree of freedom of 22. And hopefully, I'm sorry, you should be switching over to the shared screen. I'm showing you guys Table B and how we got this solution, if you're not viewing that. With that degree of freedom, 22, we go over to the left-hand column of Table B. We follow that and find 22. Highlight that row to make it easier to see. We then go to the bottom here and find 98%, because that's the confidence we want. The intersection of that row and that column is 2.508, and we have our critical value. So anything I can clarify about how to find a critical value based on degrees of freedom and confidence level? All right. Let's push on forward. Next question. Quality control. A quality control inspector will measure the salt content in milligrams in a random sample of bags of potato chips from an hour of production. Which of the following would result in the smallest margin of error in estimating the mean salt content mu? Alrighty. Real quick, if you haven't made a selection, make a selection. We're going to talk about this problem. So again, which of the following would result in the smallest margin of error in estimating the mean salt content mu? All right, and the answer is B, 90% confidence with a sample size of 50. All right, and here is the reasoning. So again, if you want to go to the shared screen in Teams, here's our reasoning here. So the margin of error is calculated by taking our critical value and multiplying by the standard error. A smaller critical value creates a smaller margin of error, and a larger sample size also helps create a smaller margin of error because the larger number you're dividing by creates a smaller number fraction. So between those two things that we have to work with here, we can kind of whittle it down, right? We can also just look at the actual options here, right? So if we have 25 in our sample, we have 24 degrees of freedom. We have 1.711 or 2.064 for 90% or 95% confidence, right? So of those two, the 1.711 would be better. But we also see when I have 50 as the sample size, I go to a degree of freedom of 40, and I get 1.684, right, which is better still, right? It's a smaller critical value and a larger sample size, so it creates a overall smaller margin of error. Now, when n equals 100, obviously that's going to create the smallest standard error. However, because we're simply making the blanket statement of n equaling 100 for any confidence level, that statement is not always true, right? Yes, for the smaller confidence levels, like basically 90% and lower, we'll have a smaller t-star value, a smaller critical value to use, but anything at like 95% or higher, it's going to be greater than 1.684. So it creates a partially true, partially false option, which makes it false. We cannot select it because it won't always be true. Anything I can clarify about this reasoning? Moving on to the next question. So we have willows in Yellowstone. Writers in some fields summarize data by giving X bar and its standard error rather than X bar and the standard deviation of the sample, S sub X. Biologists studying willow plants in Yellowstone reported their results in a table with columns labeled X bar plus or minus the standard error. The table entry for the heights of willow plants in centimeters in one region of the park was 61.55 plus or minus 19.03. The researchers measured a total of 23 plants. We need to find the sample standard deviation for the measurements. And recall that our standard error is equal to the sample standard deviation divided by the square root of the sample size. So based on the provided information, we need to calculate S sub X. All right, so we're going to talk about this one. I'm not going to push you guys to the next screen yet. So if you're still working and you'd like to enter in an answer, please feel free to do so. I'm going to switch over to OneNote. So if you guys want to follow along on the shared screen in Teams, please do so. All right, so here we have the work for this problem. We start with the known entry from this log of 61.55 plus or minus 19.03. The 61.55 is the sample mean, and the 19.03 is the standard error. Right? The way we calculate standard error is we take the sample standard deviation and divide it by the square root of n. N is the sample size. We know the sample error is 19.03, sample size is 23, we're finding S sub x. So we set up the known parts of that equation. 19.03 equals S sub x divided by the square root of 23. Multiply each side of this equation by the square root of 23 to cancel the square root of 23 on the right-hand side. Multiply on the other side. Square root of 23 times 19.03 gives us 91.265 centimeters. That's the unit from the problem, equaling the standard deviation of the sample. Is there anything I can clarify on this one? Okay, so again, it's important to clarify or identify the formula, the known parts of the formula, and then solve for the unknown. And again, here we have our solution, as we just stated. And this one's got errors, and I don't know if you guys can see this page. It's not cooperating. I forgot to fix this page. Darn it. All right, so 91.26 is the approximate solution. Here's our last problem for today. It is the big toe problem. Right, a bunion on the big toe is fairly uncommon in youth and often requires surgery. Doctors used x-rays to measure the angle in degrees of deformity on the big toe in a random sample of 37 patients under the age of 21 who came to a medical center for surgery to correct a bunion. The angle is a measure of the seriousness of the deformity. For these 37 patients, the mean angle of deformity was 24.76 degrees and the standard deviation was 6.34 degrees. A dot plot of the data revealed no outliers or strong skewness. You need to construct and interpret a 90% confidence interval for the mean angle of deformity in the population of all such patients. So the solution that I want you to type into the solution area here is that conclusion statement. Right? We are 90% confident that the interval from some value to the other value, with the unit of angle attached to it, captures the true mean angle of deformity in the population of all such patients. Right, so that's the solution that you should be typing into the solution area here. So I know some of you might still be working through this problem. That's okay. I'm going to leave this screen available. I left feedback from most of you guys who have posted answers, so please, when I leave feedback, read it. It's there to help. But now I'm going to go over to OneNote on the shared screen and kind of work through the 4-step process for this problem. All right, and again, whenever you see construct and interpret a confidence interval, you should right away go to the 4-step process. Now, in this context, I've only asked you for your conclusion statement. You don't necessarily need to write out the whole state, plan, do, conclude. If you are, that's fine. It's excellent practice. But there's that. So here we are on OneNote, and here is the work for our big toe problem. So the first step is in our process here is to state. We want to find mu equaling the true mean angle of deformity with a 90% confidence level. Right now, because I've identified a variable mu, I can use it later on. Right, so we move on to the plan part of the process. If conditions are met, we will use a 1 sample t interval for mu, right, to estimate mu. We now check our conditions under the plan process. Part of the process. Random, the patients were a random sample, so we're good on that one. 10%, we can assume that 37 is less than 10% of all such patients. And we can make that assumption because they didn't give us any reason that we couldn't. They didn't provide us with the actual size of that population, so we could calculate the percent that 37 is of that. So we're going to assume, because they've asked us to calculate a confidence interval, that this is less than 10%. We then check the large sample condition. We have n equals 37, which is greater than 30, so we can use a t-distribution. We were also told that the sample distribution had no strong skewness or outliers in the setup. So then we go to the do part of the process, and I'm going to start with listing the things that I know. All right, X bar is 24.76. Standard deviation of my sample is 6.34. That was provided in our context. With a 90% confidence, that gives me in a sample size of 37. I have 36 for my degrees of freedom. 36 does not exist on table B, so I use 30 for my degrees of freedom, and that gives me a T star of 1.697, a critical value of 1.697. All right, so now I have all the parts I need so I can do my calculation. I have my statistic, I have my critical value, and I have my standard error numbers. So we punch that all through. All right, and we have our plus or minus. The plus side gives me the upper bound, the minus side gives me the lower bound. Right, so we do 24.76 plus or minus 1.697 times 6.4 divided by square root of 37. We get the lower bound of 22.991, a upper bound of 26.529, and that gives us this interval. Right, we list it kind of like an ordered pair, and this is the interval for our 90% confidence level. And then we can do our conclusion statement. We are 90% confident that the interval from 22.991 to 26.529 captures the true mean angle of deformity in the population of all such patients. Okay. And that's the complete work that would be required to get credit for this type of question. Is there anything I can clarify? Anything I can explain in better detail? Alrighty. So again, the other thing that you guys want to think about when you're given a context like this, and we know the mean of our sample, right? Which we should know, we have to have a sample to work with. When you calculate your confidence interval, you should end up with a number greater than the mean and a number less than the mean, because the mean is the number that you're adding and subtracting a common value to. So if you end up with two numbers greater than the mean, something went wrong. If you end up with two numbers less than the mean, something went wrong, right? So make sure you're checking those kinds of things, that you're getting values that make sense, right? All right, so now we're going to end the Pear Deck, or actually I'm going to leave it up for right now. I'm going to take a look at our class and talk about the last few things we have to do here for Chapter 8. Alrighty, so I'm just going to go to the module here. We have our Chapter 8 module. All right, notice that I've started to add things that should be completed to the modules. So if you look at the module view of our chapters, it's going to tell you whether or not you've gotten credit for the things that we've done for participation, such as the activities for all the 3 sections. Right? If you've gotten credit, it shows completed. If not, it's going to show that it's not been done. All right, and then right here, these are little open circles. All right, That's because the due date hasn't passed, the suggested due date for our assessments, but it's also showing you that you need to submit this assignment. So this is an easy way for you guys to check through the things that you may have missing or that you might need to get done. Okay, I'm trying to make it a little easier to find those things. But that also leads, we have the assessments, the multiple choice and free response question assessments for Chapter 8 available. The due date, as I say, and it's really just to make it so things show up in order in like gradebook and things like that, is March 8th, right? If you have not done the Chapter 6 or Chapter 7 assessments, you might want to get those going. There's 10 questions on the multiple choice assessment. Again, you have unlimited attempts. You have the ability to look back at your previous attempts and see what you got correct and what you got incorrect and the comments that go with those types of responses. So please use that to make sure that you are getting as much credit as possible. You can retake it as many times as you want. And the free response questions, right? Let's take a preview of the FRQ/self-assessment. I've tried to give you guys a little study guide at the top. So each section has a set of like key takeaways. Right, so if you don't have notes, here's some notes. And then we have the questions. There's one question for estimating population proportion, having to do with constructing, interpreting, and confidence interval, confirming or justifying a claim based on your confidence interval, and then calculating a minimum sample size. You have to do those three things for each of these examples, once for the proportion, once for the mean. Please show all your work and try to keep your work organized. That helps. All right. And then we have our self-assessment, which this first part looks the same. Choose your level of understanding based on the work you've done in this chapter. And then we have a reflection question. It is different than the previous questions. I'm trying to do different questions each time. So please answer the reflection question. And that's it. You have all the different types of submission types available. You can do the text entry, upload a URL, media file, or just a regular file. That's up to you. How you want to submit. Yeah. So these things are all available. Also keep in mind there's a bunch of resources in the Chapter 8 module for all three sections. There's practice problems, there's solutions to those practice problems, and there's a bunch of AP Daily videos. All right, so please keep those things in mind. All right, other than that, let's see, next week, my office hours next week, I might not be able to hold those. Not that I've had a whole lot of traction on that, but typically that would be from 12:15 to 1:15. If I do have it, it will be late because I'm scheduled to get my first dose of my vaccine on Monday at around 11:40. So depending on how long that takes, I may or may not be able to offer office hours next Monday. Yeah. And so that sums it up, guys. If you have any questions, anything you'd like clarified, please feel free to stick around at the end of class here and talk to me and let me know, or send me a message later. And enjoy the rest of your day and have an awesome weekend. I'll see you guys next week.